Good morning to one and all. Today, thank you for being part of this session, FDP on 1 week faculty development program of the leveraging AI built intelligent and sustainable systems. So the schedule for inauguration ceremony is following this. Opening remarks with the convener, Dr. Raksim sir. And then coming to the, I would like to welcome to the guest of honors, Chief Academic Development Programmer, program, excuse me, Sir Dr. B. Sitaraman, sir. Next one, Dean R&D, ma'am. Uh, Dean R&D, sir. Dr. K. Venkatrao, sir. Next, Dean WNC, Madam. So, sorry for that. So next one, praise song with Dr. Priya Gupta, ma'am. Next, invite to the respective speech with the guest of the honors. And next one speech, whenever the completion of the speech at 8:50 a.m., hand over the session to the coordinators, Dr. Amit Kumar Singh and Mr. Visalakshi. So this is the inauguration ceremony schedule for this today's first session. Then first start with open remarks to the convener. Please come, sir.
A very good morning to one and all present here. I am Dr. Raksim Hatibura, Assistant Professor in the Department of Electronics and Communication Engineering. And it is my privilege to welcome you all to the inaugural ceremony of the Faculty Development Program on leveraging AI to build intelligent and sustainable systems. The program is starting from the 10th to the 14th of December 2024 at Vignan Foundation for Science, Technology and Research. It is organized by the Department of ECE in collaboration with Academy for Faculty Development and departments of EEE and BME. We are deeply honored today to have a panel of distinguished guests among us. I extend my warm welcome to the respected Dean R&D, Dr. K. Venkatrao sir, and the Dean of the School of Electronics, Electrical and Communication Engineering, Dr. N. Usarani madam. We are also privileged to have with us Dr. M. Sarda madam, Head of the Department in charge of ECE, and Dr. Z.S. Reddy sir, Head of the Department of BME. Welcome sir and welcome ma'am. I also extend a special welcome. Okay, so we have also with us Dr. PVS Sohan sir, Head of the Department EEE. Welcome sir to the event. I also extend a special welcome to our distinguished speakers, esteemed faculty members, and most importantly, our enthusiastic participants who are the cornerstone of this program. This FDP provides a unique opportunity to explore the intersection of two transformative forces shaping our world, artificial intelligence and sustainability. As all of us know, AI is no longer a concept of the future. It is a powerful, dynamic technology driving innovation and redefining possibilities across all domains. Over the next few days, this FDP will serve as a platform for thoughtful discussions, informative sessions, and collaborative exploration. Together, we will delve into how AI can be leveraged to make systems smarter, more efficient, and ultimately contribute to the environmental stewardship, social equity, and long-term sustainability. Let us use this platform to challenge conventions, push boundaries, and collaboratively redefine the role of AI in building a sustainable future. On behalf of the organizing team, I wish you all a insightful, enriching, and successful FDP. Let us embark on this journey of learning, innovation, and collaboration with enthusiasm and purpose. Thank you. Now I welcome our guest, Dean R&D sir, and Dean EEC madam to come into the dais. I also welcome Dr. M. Sarda, Madam, to come into the dais, HOD in charge, EC. Yeah. Now I invite Dr. Subhan sir to please come into the dais. Please come, sir. We also welcome Dr. G.S. Reddy sir, Department of BME, HOD sir, to grace us with his presence. Yeah. We are also delighted to welcome Dr. B.S. Raman Zanelu sir, Chief AFD to the event. So the event we will initiated by a prayer sung by Dr. Priya Gupta. Please, madam.
Hello.
Good morning, everyone. So I will offer the prayer to Lord Ganesha. सिंदूर लाल चढ़ायो अच्छा गजमुख को, दोंदल लाल विराजे सुत गौरी हर को, हाथ लिए गुड़ लड्डू साई सुरवर को, महिमा कहे न जाए लागत हो पद को, जय देव जय देव जय जय जी गणराज विद्या सुखदाता, धन्य तुम्हारो दर्शन मेरा मन रमता, जय देव जय देव भाव भगत से कोई शरणागत आवे, संतत संपत सब ही भरपूर पावे, ऐसे तुम महाराज मोको अति भावे, गोसावी नंदन निश दिन गुण गावे, जय देव जय देव जय जय जी गणराज विद्या सुखदाता, धन्य तुम्हारो दर्शन मेरा मन रमता, जय देव जय देव अष्टौ सिद्धि दासी संकट को बैरी, विघ्न विनाशक मंगल मूरत अधिकारी, कोटि सूरज प्रकाश ऐसी छवि तेरी, गंडस्थल मद मस्तक झूले शशि बारी, जय देव जय देव जय जय जी गणराज विद्या सुखदाता, धन्य तुम्हारो दर्शन मेरा मन रमता, जय देव जय देव। Thank you.
Thank you, madam. Now I welcome Dr. M. Sarda, HOD in charge, Department of EC, to give us the introductory speech.
Good morning, everyone. I welcome you all for this FDP, and this is a very great opportunity for us to learn together. I congratulate and thank all the resource persons and organizers to make this program successful and possible. I encourage all the participants to involve actively and use this program. Let's hope and wish you all to make this as a fruitful program. Thank you all. Thank you.
Thank you, madam. Now I invite Dr. B.S. Ramanjananilu sir to give us a speech with his insightful.
Good morning, everyone. I'm sorry that I came a little late because usual time is 9. I come here, but anyway, it was supposed to be 8:30, but I tried. But anyway, yeah, it's a program like Madam has discussed about it about some 10 days back. Like is a program which is useful because machine learning concepts are like they are paving the way into every engineering domain. So that way our people also will be benefited by having this kind of program. It was very really quite interesting and useful one. So in this regard, I congratulate department means, of course, I am also part of it. I congratulate all of us, and I wish a great success of this one. And I hope all of you should be benefited from this and make use of these latest trends in your research aspects. And as well as ultimately it boils down, it goes down to the students also. That is the ultimate purpose of it. I hope it should go very well, and I expect it. So thank you. Thank you. Thank you.
Thank you, sir. Now I invite Dean R&D, Dr. K. Venkata Rao, sir, to share his insights.
Good morning. Thank you for inviting me for this inauguration of this one. And about this one, I want to speak two words about this machine learning. What are the techniques we are using in the engineering artificial intelligence? Generally, these artificial intelligence where we are using the machine learning techniques, deep learning techniques also. All these are the data-based modeling techniques. So it needs large amount of data to establish relationship between the dependent and the independent variables. Thing is that we need to collect large number of samples to increase the accuracy of prediction. If you see the China people, they developed some modeling techniques called as optimization grade prediction model, like that we have. There they use very limited number of samples with poor information. Maybe 6 or 7 samples are enough for them. The trend can be anything. Using that one also, they are predicting. They are successful using those techniques in estimation of the demand for power and other resources. So in the machine learning also, you are using the deep learning techniques. To increase the accuracy of prediction, you are adding the number of layers to the model to improve that one. So that logic we know, but behind that one, what is happening, we are missing at present. People are using the machine learning techniques, logic we are developing. But what is happening behind that one? So you are adding the layers in this deep learning technique based on the loss function. That's why you are adding the number of layers to improve the accuracy of prediction. Some of the ML techniques, if you see, directly we are adding the input to the output. That is that end of that layer. So why it is required to add? What is the necessity of that one? Actually, output should give the prediction with less error. That one also we are doing. And image processing also, we are using these machine learning techniques. Majority of people know about the RoboFlow for image processing. So where we have number of techniques where we have, that is YOLO, people are using that one. You only look once. From version 3 to you have version 11 also. Now we are using the SAM also. SAM means segment anything model. And the second version is also there. Fast SAM is also there. In all these things, we are using the CNN, image processing, for that one. Even in deep learning also, we are using the CNN layers. So I think it is very beautiful. And my intention is that what is the physics behind that one? Why it is happening? That we are missing. I think if you if you concentrate on that one, it will be very fruitful. Thank you very much for this opportunity.
Thank you, sir. Now I invite Dean, School of Electronics, Electrical and Communication Engineering, Dr. Usarani Madam, to share her insights.
Good morning, everyone. Respected PSR sir, all the HODs and Dean R&D sir. Good morning, sir. Thank you so much for your time coming to this inauguration session. As we are seeing, this world is continuously evolving. We are in a state, these are the days, data-driven days. Once continuously in the evaluation process, once upon a time, something is becoming the important. In the same way, nowadays, data is important. For analyzing this data, we need some tools. Those are nothing but AI is a one tool. DS is data science is one tool. In the same way, data mining is another tool. DL is one tool, ML is one tool. In the same way, right now we are at the junction of Gen AI. So if you see this evaluation, we could not able to imagine where we are going to land in the near future. Don't think that this is image processing is not relevant to me, or this is not this is the relevant to some others. It's not like that. Mathematics addition is useful to all. Subtraction process is useful to all. In the same way, AI is useful to all. If you are working with some tool, there you are handling the data. How to handle the data in a nice way, how to do analytics from that, how to do recommendations, predictions, there you have to use this tool. And coming to this workshop, actually this workshop we planned at the beginning for the 7 days, entire days. Our sir give us the awareness that, madam, instead of going this in a one step to the bottom level, let us have the exploration in the first stage, then we will start the second stage, hands-on sessions. So keeping the sir's advice in view and the schedules of all of us, not only this, we are having so many things need to be performed. This workshop is split into 2 phases. The objective of this workshop is creating the awareness on these tools, AI, ML, all these tools at the first session. Don't think that only I am the antenna person, I am the RF person, or I am the biomedical or electrical, not like that. You go through the all the presentations, there see the problem statement, how they are using these tools in the learning mechanism or in the prediction mechanism, so that the same concept you can apply for your problem. So in that way, all the people, I am requesting all the participants, take the things in that perspective. Right now, you may be working with some particular problem. You may be working with the segmentation. You may be working with the any other problem. But go to the entire chain. Since it was planned in such a way that it exploration for various domains. First, let us have the clear idea on the entire spectrum in the holistic view at the beginning. See the power of AI. You are going to use that in your particular application, there we can give you the entire structure, how you can use it, that kind of structure we can give it in the next one to, once you are having the idea, you are acquaintance with the terminology, it doesn't take much time to explore through the things. Since all the things are available, only one awareness is enough how to use that. We are all familiar with the C and basic languages. It's not a difficult. Hardly it needs only 1 or 2 days to explore the processing of the algorithm. But creating the idea, it needs the large time. So spend these 10 sessions creating the idea on various applications. There are many real-time applications. Whatever we study in our classroom, problem may be same, tool may be same, but coming to the handling the tool is very, very different in coming to the real time. Though your machine was trained for identification of a person, that is, when you are training the machine in a particular gray level or particular lightning condition, same identification if you are doing the, whether the high intensity level or low intensity level, again your machine may not recognize. There again you have to do the some more pre-processing text. So these are the many real-time challenges are there. Many people who are directly involving in the real-time applications, they are also giving sessions to us. So clearly concentrate on the problem domains and how they are using the AI ML tools. Make a note of that. Later we will give you the design flow of how to implement the ML, how to implement the DL, in 1 or 2 days. That is sufficient to learn that. Since the same experimentation is fruitful with our BTech final year student, we did that. So first let us have the exploration of the entire area, since it was gone to the so long distance. Now only one difference is AI machines reach to the state that when if you give the single task, they are doing much better than the human beings. Only where AI is failing as of today's challenge is they are not able to do the parallel processing. There is the only gap. if you compare with the human systems with the AI systems, where we are having the gap, where we have to fill the gap is when you give the single task like object detection or classification, single task if you give, your machine will perform much better than the human beings. But if you see the driving, when human being is driving the car, he can listen the music, he can see the environment, he can control the vehicle. So many 4 or 5 tasks a person can do at a time. But that cannot be done by, as of right now, that is the gap. That cannot be performed by your vehicle. There lot of things are needed: logic, understanding, how you are seeing the world. Your machine still not able to understand the world or environment at that level. That is the only gap right now. So now we are having the challenge how to build. People are working on that. So try to understand how they are distilling the knowledge, how they are transferring the knowledge. All those processes we are going to discuss in this workshop. First, let us aware all the technical part. Next, we will use in 1 or 2 days. There we can explore the things to our specific applications. Thank you one and all for giving me this opportunity. I would like to congratulate HOD ECE and for the cooperation of the rest of the HODs and all the team members who are the part of this directly and indirectly to this workshop. I also congratulate all the participants. Participate well and take benefit of this. All the best. God bless you.
Thank you, madam, for beautifully explaining the objective of the FDP. Now I invite Dr. Z.S. Reddy, sir, HOD BME, to share his thoughts on the FDP.
All the dignitaries and participants and resource persons, a very good morning to all of you. Actually, many people speak about AI. It is a tool now. A lot of work is data processing is doing. I think we are also working on biomedical for AI and ML technique and signal processing of biomedical signal processing. Still, a lot of things are unknown. There is a lot of gap for taking this into real-time problem solving, because most of the times we are predicting. So, but what happened after prediction? We are not going to be back into the hardware, and we are not going to take that whatever we have predicted or whatever our architecture is not inbuilt into the systems. So that is a gap which in the clinical process and treatment processes which we are observed. So it is difficult for that a lot of problems to be real-time problems to be solved by using this AI. But definitely it was actually AI was my BTech elective subject. It is a way back around. I mean, it was started around 2 decades ago. But when I was in BTech, I was chosen this artificial intelligence as a elective subject. At that time, the hardware is not supported. So past 4 or 5 years, many people are speaking about AI, ML techniques and deep learning techniques. But now it is very fast and advancing tool, and it can go to all the fields. Almost all fields are using this for predictions. So in my point of view is, so we are stopping at prediction, but we are not going to be back into the inbuilt the system of these architectures and get the benefit of that predictions, which will be automatically detect anything, or automatically object detection, classifications, everything can be done from this AI. So thank you very much for giving me this opportunity. I am be a part of this workshop, and thank you so much.
Thank you, sir. Now I invite Dr. PVS Subhan, sir, HOD Department of Tripoli, to share his thoughts on the FDP.
Good morning to everybody. First of all, I would like to congratulate the organizers for taking pain in calling and inviting the experts in AI and ML. I hope these sessions given by these experts will be useful for all faculty and scholars of all 3 departments. Thank you. Thank you, Ananda.
Thank you, sir. So with this, we conclude the inaugural session, and our technical session will start from now. Now I am handing over the session to the coordinator of this today's session, Dr. Amit Kumar Singh and Vishalakshmi Madam. Thank you.
Hello.
Hello. 1 second. Yeah. Just a minute, sir.
Okay. Just write all the participants join.
Am I audible?
Join the session now. The session.
1 second.
Yes, madam, you are audible.
Yes. Okay, sir. I'll share.
Okay. Hello.
Yes, I'm sharing.
Okay, madam. Yeah. Respected dignitaries, dear participants, and my colleagues, it is a great pleasure that our School of Electrical and Electronics Engineering is conducting the 5-day workshop on the topic leveraging AI to build intelligent and sustainable systems. Our eminent speaker is from the biomedical field, will deliver the talk on the topic AI and ML in emotion classification. She came on the very short notice, and I thank Dr. Suti for that she is ready to give the opening session for the very short notice. And as we all know that this is the time for the semester break for most of the faculties of not our institute, but other institutes also. So our current semester study have already been going offline or online. So to increase the knowledge in the EI/ML field, the school is organizing this FDP with the guidance of School Dean Madam, Dr. Usharani Madam. Our eminent speaker, Dr. Sweetie, will tell you about the fundamentals of the AI ML and their application in the emotion detection. Dr. Sweetie has received the BE degree from Biomedical Engineering, Murthal. Her PhD is from IIT Delhi. She is my senior there. In 2019, she has completed. She is currently working as assistant professor in the Department of Medical Electronics, Ramaiah Institute of Technology, Bangalore. She has published several SCI journal publications and has patents also in her name. She also has different reputed awards during her career, of which she has also got the gold medalist during her UG and PG level of the study. She also has organized different workshops, seminars, and also given a lot of this kind of lectures in different events. She is also the member of the various reputed technical societies. And now I would like to invite Dr. Sweetie to start the session. Madam, now the session is yours. Thank you.
Yeah. Thank you, sir. Thank you. So I'll share the screen. Is it visible full screen?
Madam, it is not full screen. Can you
Okay.
make it full screen, madam?
Yes. Is it full screen now? Hello.
It is not coming in full screen, madam.
Okay.
Madam, it
I'll
is
do
from your end.
Yeah. I'll do just now. Is it? No? 1 minute. I think sharing options I'll change. I'll share the complete entire screen. Just let me know if it is fine now.
Yes, madam. Now it is full screen.
All right. A very good morning to everyone present there. Yeah, I'm going to talk about AI and ML and emotion classification. So if I have to talk about my background, I'm mostly working with the signal processing, and my domain is related to EEG signal processing. And in the past 1 or 2 years, I'm focusing a little more on emotion classifications. but mostly I work with the cognitive neuroscience domain, where we explore the cognitive skills, and my domain mostly focuses on attention. And so this is the domain that I'm exploring. So let's see that. So in this talk, I'll just give a little bit introduction to emotions and what are the different type of signals that or the data that we can use. And then we'll talk a bit about how we can analyze this data and how we can use AI and ML to get the task done. So let's see that. All right. Emotions, it's kind of, if we go with the content written over there, so I've written a complex psychological state. Yes, of course, it is complex. This is what we are observing when we analyze this. But though it is complex, it is quite important. So there are three key elements of emotion. These include subjective, physiological, and behavioral. So if we talk about subjective is like if I feel good, bad, angry, sad, so that is the subjective element. Physiological is when I feel sad or I feel anxious. Let's say I feel anxious, or so my heartbeat is gonna change and I'm going to sweat. If I feel happy or if I feel nervous, I'm going to have some palpitation. So these are the physiological changes that are observed when a person uh, undergoes any emotion. There are behavioral responses. So these are like if I act in certain way, if I'm feeling bad, my behavior will be, if I'm feeling sad, my behavior is going to be different. If I'm feeling happy, angry, so that will be reflected in my behavior. So these are the three elements. If I want to classify emotion, it's not that I'll just acquire the data and I'll just use the advanced algorithm present and I'll feed the data to the network. I should understand the data first. So that is why we need to understand what are the different elements related to emotions. So these are the three things, and people in this domain try to explore these elements, and people have different opinion about the classification process. So we will just go through with that. But before that, let's see the application part of this study. This study domain is quite interesting, and it has lots and lots of applications. I have highlighted few over here. So I'll just name few. In education, people are studying the effect of learning platforms and taking the feedback from the students. It's not their oral feedback, but the feedback from their, let's say, expressions, the way they are giving surveys. Then security and surveillance is another domain where we have the lie detection, and when we are telling lie, our emotion changes, and if we can detect it, though the modality or the data that we are going to use for this detection is going to vary in all these applications. It's not that I have just one data and I am going to get the classification done. So data is going to vary. Anyways, the next is human computer interactions. So to create the interactions, better virtual assistantship, we need to understand the emotions. Social robotics, it is something which people are thinking. It's already there, but people are thinking to make it more social. So this element can be added to the robotics if we understand emotions better. So we can have companion robots, healthcare robots, and R&D is of course there, where we try to understand emotions. Marketing and customer experience, all the websites that we are designing, all different type of that we are designing, how customer is experiencing that, what is the feedback of customer. It's not only on the basis of the survey, but trying to get which part of the ad subject is focusing more. So this kind of data can be collected and analyzed to improve upon the customer services. So that actually is something which is altogether a different research domain. Then we have health and tech. So my main focus is on healthcare and therapy. So it's about mental health, monitoring, biofeedback therapy, and rehabilitation. So why we need emotional studies in healthcare and therapy? So there are people, I'll just take one example, people undergoing certain kind of, let's say, hemiparesis or some kind of spasticity issue, or they have some, after some accidents, they have permanent limb damage. So they have certain issues, let's say mental health issues, they are not able to communicate, they are not able to tell their issues. So if we are able to understand their emotions and help them, there are rehabilitation and biofeedback therapy where we can understand patient better and help them in a better way. So these are the applications, and yes, of course, we need a lot of understanding of this domain to make it practical. So let's explore more. So emotion classification, it's the process of identifying and categorizing human emotions using data. The data that I was referring before as well, data can come from different resources. It can come from our own body, physiological signals, facial expressions, and let's say if I'm laughing, smiling, all right, this is what this is what is proposed. Textual data is something. So textual data is like when you are, let's say, on your Twitter, or you are writing something about some issue. So you have written one sentence, and we are, if you are able to, let's say someone has written one sentence, you want to make meaning out of it. So how are you going to understand that? So we have our inbuilt NLP, so we can understand the content about it, like the context of it, whatever is written, we are able to understand it, the emotions behind it. The way we are writing something will actually reflect our emotions. So we can gather such type of data to understand the emotional aspect of person. So that is the textual data, the way we are representing our thoughts, or by text we represent our thoughts. So point is, can we understand emotions from the text? Then is vocal features. When I talk to someone, let's say if I'm nervous, there is going to change in my vocal. If I'm excited, I'm going to talk it differently. If I feel really happy, the tone will change. So this recording can help us understand emotions. So this is another, that is another possible data set that can be used. And of course, there is multimodal data sets. Multimodal data set is like we can use the vocal features and the facial expressions, and we can merge these data set and then do the analysis. So we have so much information, but now question is whether this information is going to give us the correct result or not. Trust me, people are there who are focusing on all these data sets and they are getting good results. But my opinion about these different data sets, because my focus is majorly on the physiological signal, so the way I perceive these data sets is a bit different. For example, if I talk about facial expressions, let's say I'm feeling little annoyed, and I'll make my facial expression, I'll just laugh it out and all that. So manipulation is there. If you want to understand the real emotions, there are there is this chance that we can actually fabricate our facial expressions, and textual data is there, vocal features. Again, my this is my aspect. Definitely there are people who are using it and it's really working very well. Then but my point is, when we are trying to understand the real emotions, so I just go with the physiological. Hello, is it audible?
Yes, madam,
All
you
right.
are audible.
Okay. All right. So when I want to go with the emotion classification, I think of the physiological signals as the best option. So let me just let's just go further and I'll talk a bit about the part physiological signal. So why I appreciate the physiological signals to classify emotions. So there is this big, huge list I have put that includes heart rate, electrodermal activity is related to our, let's say if a person is telling lie, the sweat, the amount of sweat that will be secreted is going to increase. So this is the activity that will be elevated. ECG, again, there will be change in our ECG, EEG, our brain signals, facial electromyography, EMG signals. Instead of taking the pictures, the, let's say, happy face picture, instead of that, we can just take the facial EMG. Respiratory rate, it changes. Like there are people who are expert in line, they can actually manipulate certain parameters, but it's not that easy for everybody to do that. So respiratory rate is something that will change with our emotions. Also blood pressure, the pupil dilation, body temperature, and so on. Okay, chalo, vocals also, that will change. All right. So these are the parameters which people are actually using to classify emotions. And my interest lies with the electroencephalogram, EEG. Yeah, it lies with the electroencephalogram, which is EEG. These are the brain signals that we acquire when a person undergoes different emotions. So this is what I'll be talking about, EEG. All right, and okay. So of course, when I talk about EEG, the data set is huge. The data set is really huge. If we use EEG signal to analyze any activity, we start with at least 32 channels, and number of channel keep increasing. So if you want to do such emotion studies, I'm not talking about the product. Of course, if we go with the product, we prefer to have two channel system that can actually classify the emotions. But if we go with the study, we prefer minimum 32 or 64 is average. These number of channels are required. So if I have to analyze 64 channel data, it's not that easy if I just start processing it. But yes, of course, we are doing it from last many years, analyzing the data. But now we have the option to use AI and ML. So AI and ML can help us handle such type of data. So it can help in multimodal data handling and data processing. So if I have to analyze the data, let's say I have sampling frequency of 1024. So let's keep it even. Let's say I'm getting 1,000 samples per second, and I am recording it for 24 hours. So we can multiply and do the calculation. So the number of observation that I'm going to have, it will be 1,000 into 60 into 24 for 24 hours if I'm doing. So the number of observation is huge, and the data size, if I have to see, it is going to be multiplied by 64 again. So the data is huge. We can use AI and ML and its computational abilities to analyze such data, and they are helpful in the pattern recognition, real-time analysis, and emotion detection. So
అడిగాం మేడం రెగ్యులర్ లేదు అంటుంది ఓకే అని వదిలేసారు
okay, when we talk about emotion classification and detection, I think someone's mic is on. Okay. So when we talk about emotion detection, most of the applications involves real-time analysis, and real-time analysis needs high computational abilities, and this is where our AI and ML models can help us. And in this domain, there are different algorithms that are explored that includes supervised learning algorithms. For example, for the sentiment classification or emotion classification using label data, and there we have algorithms like support vector machine, decision tree, naive Bayes classifiers, algorithms, And unsupervised learning are also there, where we have clustering physiological signals for the emotion detection, and the k-means and other clustering algorithms are doing well in that. But then we are shifting to the deep learning approach, where we have different networks like CNN for image-based emotion recognition, and we have other algorithms like recurrent networks, long short-term memories networks. These are for the sequential data, the data that I'm talking right now, like speech or EEG data. So we can analyze our data using the deep learning algorithms as well. But thing is, up to this point as well, the supervised learning algorithm and unsupervised learning algorithm, they are doing quite well. But yes, we have the computational abilities, so we can go with the deep learning. And this is what is the current trend now. All right. So let's talk a bit about the EEG signal related emotion classification. So we have different data sets that we generally use. It's not that easy to acquire and create the database. So we just go with the standard database that people are using to verify our algorithms. So in this context, we have the data sets with respect to text also, audio, and for the multimodal data set, there are two very famous data sets. This is one is deep and another is seed. The deep data set, University of London, they provide it freely. You have to just sign some undertaking. So this is the data set which provides insight into the different emotions, and this is one snapshot of this data set if it is visible. So this data set, it has, this is one online self-assessment rating. So the one thing that they provide in this is online rating. Person is going to do the rating by themselves. The subjects, they will rate uh, using one self-assessment protocol given. And they are shown some videos. So there are around I think 30 to 40 videos which set is there that related to different emotions. They will be shown to the subjects, and then accordingly their data will be taken. And the online rating is there. Then there is another data which is participant rating. In this, the rating or ratings participants gave to the videos during the experiment. So first thing is the online self-assessment is done. They are shown the videos and they are supposed to rate the videos. It means if I'm showing certain video to the person, to the subject, and I'm telling this is a video that will be labeled as happy face or happy emotion. But the other person, subject who's seeing the video, is not perceiving that video as happy. That can be the case. If something feels happy to me, it may not be giving the same emotion to the other person based on the real life experience, or they might have seen that video before. So participant can rate the video. If they say how much, they can give the rating. If I say happy, they can give a rating, yeah, 3 or 4 or 5. Yes, they felt happy after seeing the video. And they are given some questionnaire, and also their facial videos are recorded. And then comes the physiological data. The physiological data is collected, the EEG data, from 32 channels, and yes, along with the face videos and other questionnaires. So in this kind of studies, when we are doing these studies, it's really important that if I say emotion, it's not that easy. I'll just give one video to a person and tell watch the video and I'll record your data. I'll put electrodes on your head, I'll record the data and I'll put it to my algorithm and classification done. It's not that simple. When we are acquiring the data, our protocol should be well defined. If I am taking the emotions, I should see if I'm able to stimulate the same emotion that I'm looking for. So the data should be selected in such way. That is why in these type of standard data set, they have done a really good job where they are actually taking the patient's feedback, their rating, and their assessment test as well. All right. So in this data set, they have designed different emotion dimensions, including valence, arousal, dominance, and liking. We'll just talk about two because the data is huge. Let's say there are two dimensions that includes valence. And if you see this representation, in this representation, you can see we have valence on the x-axis, arousal on the y-axis, and these are the different emotions that are mapped. So let's say this x-axis. So valence is high. So first, valence is actually quality referring to intrinsic attractiveness, goodness, or badness of an event. Arousal is having strong emotions like anger, fear. So one person, let's say, positive valence or valence is high, and let's say arousal is high. So that will denote emotions like happy and excited when both valence and arousal is high. So these are the emotions, excited and happy. Basically, this represents a 2D representation of the emotions. Similar way, you can see the other quadrant here. We have angry, afraid, sad, depressed, calm, content. So this is the representation, and we have to segment out the data. This is another challenge. So basically, I'm talking about the challenges when we acquire the data, what is the challenge? And once we have the data, what is the challenge? So at this point, our major challenge is about segmenting the data or labeling the data. Or in other words, I can say segmenting the labeled data if we have the labeled data. So when you are acquiring the data, it's not that you will just show one type of emotion. You will be just showing happy for 1 hour, then sad for 1 hour. It's not that. You'll be showing certain videos and you are going to change your protocol. Randomly, you're going to show the videos and then you will see how the emotions are stimulated. So in this case also, when once you have, let's say, balance emotions is there, then arousal is there, you have to label out, you have to segment out, and then you have to see that that segmented arousal portion and its rating given by the person, if it agrees or not. If the subject is telling that with this respect to the video, he is feeling the emotions like, let's say, happy, then only you have to take that segment, otherwise you have to remove the segment. Person's rating should match with the emotion. If person is telling he is or she is feeling happy, then only you can take the data. So such type of data sets need a lot of processing part. Now, once you are able to segment out based on the patient's rating, online assessment, and your video, all three things should match. They should tell happy, happy, happy emotion. Then you can take that data segment. So once you have the data, then you can arrange your data. So now this is just one kind of uh, flow chart I'm just putting just to give a picture like how this is the basic process that we follow to analyze the signals. So let's say we have our EEG signal that I just was discussing, and this EEG signal is the one that we got after video rating and all the estimations are done. We have the EEG signal, and pre-processing steps involved different other algorithms are applied. So one of them is, like I mentioned few here, noise removal, downsampling. There are other things that we need to do that includes epoch selection, their labeling, their segmentation. So there is a whole lot work in pre-processing part. Once you are done with the pre-processing of your data, so at this point, I'm just talking about EEG signal pre-processing. I'm not telling how to prepare this data for the training model. All right. So now we have the pre-processing data, and this data, how are we going to use this data now? I mean, sorry, how we are going to utilize our machine learning algorithm to process this data, isn't it? I mean, I have the data directly, I can't feed it to the network. So few things are there which are required when I talk about emotion classification. When we acquire the EEG data, so the data that we acquire, it is from the scalp. So the sources are under the scalp for the data, isn't it? But we can't open the scalp and take out the data, which is really not uh, possible in normal scenario until unless it is some surgery case or anything, some such type of case. So there is this process, we call it data localization. So prepare the data. One more step we can add, it is data localization. So the scalp data, in this scalp data, there can be overlap of sources, but we want to segregate, or we want to separate out the sources with respect to the different region on our brain. Let's say frontal or frontal, prefrontal. You want to if there is certain overlap in certain locations, you want to separate it out. We call it source-based analysis as well. So data localization will be done where ICA or component analysis is done to separate out the sources. Once you separate out, then we can further analyze this data. Again, we are preparing it for our AI. Please don't get bored. We are preparing the data for our network. So then again, we have this channel selection based on dipole. I'll just move to this slide just to discuss this part in a better way. So data localization, let me just use another slide to explain this. So once we have processed data and everything is prepared, we'll use the ICA algorithm to analyze this data. So what is this ICA? It's a signal processing method to separate independent source linearly mixed in several sensors. The same thing that I was talking about. If we are taking the data, there is huge overlap of sources. So that can be done. So ICA identifies temporally independent signal sources in multi-channel EEG data, as well as their pattern of projection to the scalp surface. So now when we can apply ICA and we can have the independent components, and these independent components we can map. So there is this one illustration that I'm showing here. So this is one of the component I'm just putting here. It is one component 22, just one component I'm showing. Like that, we are going to have 32 components, and we have to see which component is dominating. So in this particular case, this particular component, which is going somewhere around nearby some central temporal region, so that component is contributing approximately 45% to the activity. All right, so once we have this component, this gives us one idea that these are the channels, or these are the components which are actually contributing more. So if we want to do any kind of classification, we can use this component. Basically, we can utilize this step as a feature selection process as well. All right, so this is one way to select the feature. So we are able to map our independent components, and this gives us, and other than that, actually, if you want to go further to analyze it, we can localize these components, and we can perform the dipole fitting to see where exactly this component lies. So this is example of one mapping that I have given. So let's say we are able to localize ICA component, and it is telling us that, let's say, parietal region is more dominating. So, and it is giving us the dipole information. We can map these dipole information. There are softwares like Loretta. We can use certain softwares to map these dipoles. So that gives us the better picture about these different components. So this is something can be done. All right. So now we are at this step when in certain way we are able to select channels based on the dipoles. So now our data is ready. We can use these selected channels. We can feed to certain training model, and we can classify. This is something we can do. So this is what it shows here, that we can select the channel, we can select the data, feature selection is already done, and there is a strong base to select those features, and we can use any algorithm. For example, support vector machine is something which is for two-class classification we can do. We can use that model and we can classify the data. We can feed this data. Other than that, if you let's see the second part of this flow chart. So first part, I hope it is clear. Please do ask me if any doubt about the first chart, this first part of this flow chart, this flow. I hope it is clear. If not, please do let me know. All right. Okay. So the next thing is using, all right. So next thing is, if you want to use deep learning approach, how can you go with it? If you want to classify emotions, you really want to use the better computational capabilities, you want to utilize the new algorithms, how can you do that? There are different ways. Like I told you, LSTM networks are something which are really great when you talk about sequential data or any physiological signals, and recurrent networks, they can be utilized. I'm just putting one example over here. So this is one of the example. There are possibilities are enormous. So one example is, once you pre-process your data, once your data is prepared, what you can do, you can create features. So now let's say you are interested to use CNN. Okay. You don't want to use LSTM for sequential data and RNN, and you are interested to use CNN, let's say. All right, so what to do about this data? So there is this option, this feature that we can calculate. It is a scaleogram. It is a frequency representation of your data. And you can use continuous wavelet transform to generate the scaleogram of your data. So basically in our EEG signals, what do we have? We have, it is different frequencies, and different signal of different frequencies are present, and if we can put it in form of image, that is what known as scaleogram. So we can have scalograms, and those scalograms in form of images we can feed to the training model, and we can perform the classification. So two things can be done: either you use your raw data, your physiological sequential data, and perform the classification, or you can convert it in form of scaleogram and you can use it to feed to your network. So this also can be done. All right, so once we are done with the feature extraction, so this is another representation of this. Okay, so this, all right. So this is just one example I took in this process. So let's say we have our EEG signal, same thing, referring to the previous flow chart only. So once we have our signal, we are creating the scaleogram. This is one sample scaleogram that I'm putting over here. So if we have these such type of scaleogram in form of images, we can feed it to the CNN and we can perform the convolution to classify it. In this particular classification, we have put LXNet, which is kind of a really basic network, and more people for right now we consider VGGNet and all that the better options, but I just took the basic network, which is LXNet, and to classify, and this network also is giving 86.5% accuracy. So what is this LXNet? If I have to give a basic introduction about it, so basically if I say LXNet, it's we are feeding images. It's a pre-trained network, and we can utilize these type of pre-trained network for our classification for this type of data, which is EEG. So we can use this training model from LXNet, and that also can give us the output, though it is not the best option, but this still help still but still this can work. So in this example, we used LXNet. And if you see this basic architecture of LXNet, the input image size, it is required is 227 into 227. So this is what we have to create. You must be using LXNet for different applications, but here I used it for the emotion classification. And when we are generating the scaleogram, those scaleograms size should be 227 cross 227. So this is something we need. So convolution in this LXNet, we have convolution max pooling. I guess people are comfortable with all these basic terms. I'll be just giving a brief about it. So when you have image set, which is let's say 2 to 7 cross 2 to 7, and size, this is the size of the image that we are feeding. So it will go to the convolution network, and then the max pooling layer is going to help us to decrease the size. So this is what happens. So you have first convolution, then followed by max pooling, convolution followed by max pooling. Then you have three convolutions layer, then finally max pooling, and you have this fully connected layers. And then you have the final one is your classification layer. All right. So in this arrangement, we can feed our data and we expect network to behave and to classify the data. Different type of networks are used in this domain. I'm just putting the name over here. For example, CNN, LSTM, MLP, which are fully connected autoencoders are something, and hybrid algorithm are something that people are exploring. So if we look at the emotion classification, so CNN, it has automatic feature extraction and of course good for spatial patterns. And the challenges require large data set. Anyways, the data set requirement is always there, and it the results that are shown are within the range of, let's say, 80 to 90% for binary classification. So this is the binary classification. But when I talk about emotions, it's not binary. The example that I gave you, there we had the four quadrants, if you remember, with respect to low and high value of valence, and same way go for the arousal. So I was talking about the four classes. So CNN, if you are using for emotions, this is the accuracy, that to be for binary. And LSTM also, it's stated 85% using EEG. And then MLP is there. They have less computational requirements. And yes, of course, they do not capture the spatial patterns and reduced accuracy. Autoencoders are something, but yes, not recommended. Yes, hybrid algorithms are there, which are some options that can be explored, though they are going to need a lot of computational, they will have a lot of computational requirements. But the accuracy that is reported, it's really good. It's going around 95. So 95 looks real good if we use it. So in this, up to this point in my presentation, I basically discussed that we can have the data, and when we acquire the data for emotion classification, it should make some sense. Simply, I can't just capture the image of someone's face and feed it to the network and expecting 100% result. All right, and then we saw we can use the sequential data for the classification, we can use the networks, and we can convert them, the features, into the images, and we can again do the classifications. And yes, challenges, these are the definitely typical challenges that we face. Data issues and cultural variations. If I am Indian, my facial expressions will change, and other parameters are definitely going to vary. And if another continent, these variations, demographic variations will be there. And multimodal fusion, people are trying, for example, performing the classification using facial data and then other physiological data. This is something, it is going on, but the results, some results, actually there are some of the results that are given in the literature which are actually really good. They will state 100%. You might have seen it. Some of you might be wondering, already 100% results are stated, and we have systems to detect the lie, which claims to give 100% results. But now point is not about 100% as of now. Point is whether the classification is correct or not. It is 100% if it is classifying, but whether it is correct or not. If certain emotions we are classifying, so we have to be careful whether the same emotion is there in that person. If the person is thinking the same way that we are perceiving, there can be difference. So that is why people can fake it. Ethical concerns are there because emotion data, if we are sharing, so that always comes with ethical concerns, but that can be handled with the care. And yes, of course, in the future, people, everybody nowadays, they are talking about the explainable networks. Like I'm telling you just now. Just now I told you, if I'm feeling certain emotion and my data you are collecting and you are classifying my emotion as, let's say, angry, and I'm making angry face, but whether actually I'm feeling angry. So those kind of reasons, those kind of explanations we need. So that is why in this domain also people are asking about explainable AIs, and real-time emotion detection using EEG is again a challenge that we people are working with. And depending demographic changes, they needs to be adopted for the system that we are trying to develop. So this is one introduction to okay, this was one introduction to the emotions and how this domain works. And of course there is so much in this domain. I just try to give a basic summary that what is emotion and how we look at emotions. Now if we have the data, let's say, let's talk a bit about I think just a little bit of demo, if you people are fine, just to see that. So I have taken two things here. First, I'll just talk about my data, the data that I was telling, and some of the challenges that we might face when we analyze the data. Here, I'm just taking, is it fine, Amit sir?
Yes, madam, you can proceed, madam.
Okay. So, right. So, basic, some discussions we'll do here, basic discussion about it. So, I've just taking this data. It is the EEG data. So, these are the features related to the 32 channels. Most of you, many of you must be working with EEG channel, EEG data. So, I just took this data. Its size is 8034 cross 32, I should say. So 32 channels we have, and the data is taken. So now when we take such data, the very first challenge that comes with it, it is about pre-processing this data. Whenever you have any data, so handling this data is, yeah, handling this data is another challenge. So few key points I would like to highlight about it. The first thing is, let me just take this another Google Colab file. Okay. All right. All right, so this is just to show you that how this typical EEG data look like, and these are the extracted features that I'm putting. It's not the raw data, and these are the features that are given here. So now point is, when we acquire the data, the very first challenge is about the missing values in it. So all the handling of the data, how are we going to handle this data? Let's say I want to, out of this 32 channels, I want to work with, let's say 5 or 10 channels, let's say. Out of 32, first level, I want to reduce it to 10 channels. So how to go about it? What is the basis? What is the criteria to select this data? If I have some features, how I'm going to select? For example, let's say we have a feature, we'll take simple feature, let's say mean. I just want to put a threshold, that I will set up a threshold that this standard deviation or mean, if this is the range, I'm going to consider these readings. If not, I'm going to go with the other part. So in this another Google Colab, I'm not taking the EEG data. I just, okay, I'm not taking the EEG data. I'm just taking one data frame that I just created just to talk about the data handling issues that we might come across. So in this, we are just using the basic pandas library. And what I've done here is just one data frame is created. And in this data frame, the data looks like this. We have patient ID, which is not going well. But anyways, let's assume these are 1, 2, 3, 4, 5, 6. So we have patient ID and some data related to age, gender, and some marks is given. And yeah, the one thing when we talk about the data analysis in our EEG also, when we are acquiring the physiological data, that includes, we will be having physiological data and some of the data like subject's opinion or assessment survey. So that data also will be fused with the whole physiological data. So we need to segregate this data, or if you want to process the data, maybe you can map it. For example, in this case, we have our data with respect to subjects, and then we have the gender, which we are putting. It's not here in this data. Yeah, it is there. So we are just putting male, female here. So you can have categorical data in your data set if you want to change it. So you can't carry forward with this data. The first thing that you should do is to map your data. Though this is kind of a very simple example that I've taken, but same thing you can apply to data set like this, EEG data set. This is better for actually explanation. So that's why I'm just taking a very small data. So the very first thing that we always need to do is mapping the data. If you have this categorical variable present, so this is one thing we can do. Another comes with the filtering of the data. So in your data, let's say, for example, there are 32 channels. Out of you have to see how effective is your data. Out of those 32 channel, how many data sets are performing well or not. You have to see. Sometimes what happens when you acquire emotions data with EEG, the impedance value might change, or some of the electrode might be loose, though it is going to give some of the reading data. You will see some readings, it won't give 0 0. Some data is going to come. So you have to see whether the data which is coming to that particular channel, let's say I'm putting frontal 3 channels, right? And after 24 hours, this uh, FP, the electrode on frontal lobe, it is loose and it is not giving the correct data. But I'm seeing some values. I can't take that data. So I have to see if the data is correct or not. I have to analyze if it is EEG or it is just noise coming. So for that, you need to analyze the parameters, how I can find out. I mean, this is a domain knowledge, how I can find out whether this is EEG or just noise. So for that, if that is the case, you need to filter out that column. You can't do anything. There is no other option. You have to just remove that column. You need to find out, maybe you can use some threshold to see if the data is wrong or is it noisy. So that is another possibility. You can set some kind of, let's say, if you have the data frame with you, you can just see if some threshold values give, you can mention some threshold value and you can see if you have such data. For in this case, let's say you are putting some threshold value to this particular parameter, and if the value is more, it will display and you want to remove that. So that you can do, you can remove that part. There is another issue. Okay, so you can remove that particular column only. So maybe if 3 electrodes were loose, you end up with 29 columns now. Another issue is about the missing values that may look repetitive, but this is something we should always discuss when we talk about the data. So in the data, there is this challenge which is about the missing values. Now we have to handle these missing values, and how we are going to handle is, again, it is not that there is a strict rule for this. It's not that I'll tell you if missing value is there, you remove it. If missing value is there, replace it with something, or if missing value is there, do something about it. There are different options that can be done. For example, let's say we have this data, and just again, I'm just taking this small some data randomly. So we have the data, and in this data, there are some values missing. Let's say this weight, none. So some values are missing. I have to find out that in first column, if is null, right? So I'll just use typical math, Python function. So I'll just find out is null there. I'll get truth if value is missing. So I can count the number of true values in this particular answer. That is something I can do. No? So I'll just write is null dot sum and then bracket. If I do that, I'll just see if it works. Okay, so it is telling there are two null values. Fine. So now I have to take a decision. Out of these are seven observation, two are missing. Whether to remove this column as well or to replace these values. Okay, so if let's say I have 8,000 values, and if this sum comes around 10, okay, maybe I can remove those observations. But if it is more, then I have to take the decision. All right, but anyways, now we know that there are missing values, and we know the total also, that there are two values missing. I want to replace these values. So there is this solution which is very well accepted. It is replacing your missing value with the mean. This is kind of a solution that actually works. All right, so what we do in the same feature, let's say here it is weight. In the same feature, we are going to fill the mean value. So we'll fill the mean value, and this is the typical syntax where we access the feature. We fill the nil value, sorry, NN values wherever we find, and with the mean. So once we do that, these null values will be replaced by mean of this feature. Okay, this may, if it doesn't go with your study, you need not to replace it. You just remove the observation if you have a lot of data. All right, so now we see that there is no missing value. So this is something we can do. Another important thing that we can do with the data, and it is about normalizing our data. So we have our data set. Okay, we have our data, and you can see, okay, you can see the values. It starts from 54 and it goes till 99. Isn't it quite a range? Right? It's like we have this data from minimum is 54, max is 99. So there is this normalization operation that we can perform. It is a scaling process. So what will happen? Your data will be scaled from 0 to 1. So if we apply scaling, let's see if I have the result here still. Yes. Okay. So we can perform the scaling, and these values will be scaled on a scale of 0 to 1. So that is actually gives you a better handling of your feature. So you see there, so we have the weight from 54 to 99, and the normalized weight, it is from 0 to 1, max is 1. So minimum will be 0 and maximum will be 1. So this is a scaling that also helps in the better management of your feature and for the better processing. So this is something we can do. Now, this is normalization we are doing. All right, so once these are certain operations which are quite important if you analyze your data. Once your data is ready, after that, of course, you can feed it to the network the way we discussed. Maybe you can feed the raw data and use the learning algorithm in such a way. You can't just feed CNN whatever you like. I mean, you have to to arrange or prepare your data as per the requirement of the network. And I think this is about the pre-processing of the data, some basic things I wanted to just discuss. And yes, we can use the data with the network. And one last concept that I want to just discuss, when I was talking about emotion classification using other uh, modalities, for example, images also. So I just want to show that part as well. So this is just one data set which is given. I'm just talking about this emotion images. So the one I showed you was for the sequential data, EEG, and this one is, these are the images. So this is one freely available data set. It is emotion data set. And what we have here is angry face data set. So this is some data set which is created, and people from different countries are there, even some from India as well. So they have created this. This is angry face. So you can see for this person, the angry face, and for this person, angry face, it differs. So I'm just showing you this data set or this last bit just to make a point that if we, okay, face detection is something, right, we do, but when it comes to the emotion classification, there is a lot of variety in the emotions. So if we see emotion of this person, all right, yeah, it's not that visible. There are, if, okay, the image size is actually 48 by 48, so it's not that visible here. All right, so the size, the facial expression varies. The way I feel disgust and the way I feel other person feel disgust may be different. Okay. So if we have to use these data sets, so this is just one example I took, and a basic CNN is applied on this same data set. It is a freely available data set. You can download it. It is face expression recognition data. And let's say we have the basic library, and if I'm using this, the typical CNN, and this data set, it is already available in a split form, that is in train and test data is already there. So if we want to see, so it is just that train already trained it. So they are using the convolution network is used here, right? So these are the typical layers that involve the convolution, normalization, followed by activation and max pooling. And convolution, after convolution, we have the max pooling to reduce the size. You can see 48 cross 48 image size is there. So we are performing convolution on that. And then max pooling will reduce the size to 20 and by 2. So it is 24 by 24. Then there is dropout layer. It will drop some of the features. And then we have convolution 2D. And this is again performing convolution followed by normalization and then activation. Again comes the max pooling layer. So what will max pooling layer do? So it again by 2, it is going to reduce the size of the image. So image size is going to be 12 by 12 now, from 24 to 12. Then again followed by dropout, convolution, batch normalization, activation. One more pooling layer is put, and that again reduce the size further to 6 by 6. And in same followed by the similar layers, in the end we have our 3 cross 3 size image, and after flattening we have total calculation comes to 4608. Okay, 3 cross 3 features were there, and you flatten it, you multiply this, the value will come to 4608. Okay, so this is something is there, a typical convolution network. All right, and yeah, so if you use that, I just wanted to show the result for this data set. Okay, let's see if still, yes. So what happened if we use, so I didn't use the advanced network. I'm just using a typical CNN on these images. The other algorithm may work better. So what happens, let's say true feature is angry and predicted is neutral. Similar way, if person is angry, predicted it's angry, correct? Angry predicted sad, angry predicted neutral. So true emotions, like projecting the true emotions or perceiving those true emotions, it's still a challenge. If I just make this face, yeah, I'm happy, algorithm will understand. But if I'm happy, I'm not too expressive, then algorithm won't understand that. That is why, according to me, though people are exploring this domain a lot, according to me, we should look at the physiological parameters, and maybe we can look for the multimodal approach where we will integrate emotions and facial expressions and EEG signals together to come up with better classifiers. Yeah. Yeah, that's it from my side. We can discuss if there is any question from audience.
Hello. Now I open the session for the any questions. Any participant who want to ask any question, they can ask. Any online participant can ask the question to the expert.
You can write in chat as well. I think it's fine, Amit sir.
I think nobody want to ask the question, so we will.
All right.
So we will wrap up the session. So dear participants, our school is very thankful for the management, especially the chairman sir, VC sir, registrar sir, all the school deans, and all the HOD, especially the EC department and the biomedical, who successfully provided their valuable time and support to conduct this event. Furthermore, I am very thankful for the expert who enlightened us with the knowledge in the field of AI and ML in the emotions and its classification. She also told us about the emotion classification challenges and the future prospects of the technology. She has also given one live demo. And this is the memento for you, madam.
Thank you, sir.
As it is, you are online, so I have to share it online only.
Yes, please share online. Thank you so much.
I hope the knowledge provided by you will help all the participants to understand the different emotions that are generated by the human in different aspects of their life. I'm also thankful for the support of all the department faculties, whether it is from EC, BME or the EEE, and to provide their valuable time for conducting and completing this event very successful, especially this session. With this, I would like to thanks to the expert, Dr. Sweetie, for providing her valuable time and for this FDP and coming for this session for a very short notice. Very thankful, madam.
Thank you, sir. Thank you for the invitation.
Madam, you will Dean, madam, will say a few words.
Yeah, sure.
Thank you, Dr. Sweetie.
Yes, ma'am. Thank you, ma'am.
Like your name, you are also so sweet. We
Oh,
are very
thank you.
glad to be here. We are very glad you are be here. That's a area where a lot of research is going on. Many things need to explore. You have taken all the three kinds of parameters. Our people get benefited out of this. Thank you so much for being with us and delivering a good lecture to all of us.
Thank you, ma'am. I
God
hope
bless
it
you.
will work. It was quite.
God
Thank you
bless
so
you.
much, ma'am.
We wish all the success in your future endeavors. Thank
Thank
you,
you
ma'am.
so much, ma'am. Thank you. Okay, sir.
Thank you, madam.
Then I'll leave, sir. Thank you.
Thank you, madam. Thank you. With this, I will ask the participant to leave. And I will also like to say that Second session will start at 11
Today,
p.m.
we celebrate not only an esteemed appointment, but also the values of leadership, dedication, and excellence that this rank symbolizes.
All the participants, a small request. This workshop is conducting
Now,
on behalf
I
of
invite our
AFT.
esteemed dignitaries to the stage.
On behalf of AFT, Faculty Development Academy, as well as Department of ECE, Biomedical and EEE, you need to fill the session-wise attendance sheet. People will be shared to you after completion of the session. And to self-test yourselves on the session, there may provide 4-5 MCQs. You please do that and upload those 2 forms to make you active in the session, to check your self knowledge on the session. We provided that opportunity. Please make use of that opportunity.
Thank you. MCQs will be shared in the WhatsApp group. WhatsApp group we will share.
Thank you all. Thank you all the participants. We will meet in session 2 at 11 a.m. sharply. All of you requested to join 10 minutes ahead.
Thank you.